start off with a homework question from 1.5. Problem number 3. Oh, that's in that. Okay. Thank you. Let's see here. So these here are our 3 equations, and we're trying to find the solution. And the solution for this one will be a single point. Now, for this here and all the ones that we had on the assignment, when we picked the eliminator equation and the variable we're going to eliminate out of all 3, we've had a nice choice across all 3. Because the first and second equation, the number in front of x is 1, so we can easily turn it into the other 2. With y, the top equation is 1y, so I can easily turn it into 2y, 3y for those to eliminate. And z, the bottom 2, 1 in front of them, so I can easily turn it into all 3. Now, I'm going to change this equation just for a second. Let's just say that this was plus 5y. I wouldn't eliminate y to start. Because even at the smallest one, 2y and 5y, to get them to be the same, I'm going to have to multiply both equations. 2y and 3y, we're going to have to multiply both equations. So if this was the case, y is not a good choice to start with. It would work, but we're having to do more steps. I'm going to have to multiply the equation with 5y by 2 and the equation with 2y by 5. We're having to do more steps to get them to be the same. So at this point, we can just pick. We can do x. And I'll pick top or middle equation. Top is going to be our eliminator equation that we're going to eliminate x from, and we can write out the other 2. Negative x plus 2y plus z is equal to 2. And we'll have our other equation, 2x plus 3y minus z is equal to 9. Now, since our eliminator equation and the one on the right are already the same value of x, I can list it underneath because 1x and 1x, they match. Signs, we're not so concerned about. We just need the number in front of them to be the same. Questions on that so far? Since they're the same, we're going to either add the 2 together or subtract them from each other. Now here, negative x and x. If we add, negative x plus x would be 0. Negative 1 plus 1. If the signs are opposite, we add. If the signs are the same, we subtract. So since we are doing addition, we're doing addition across the whole thing. All right, guys, let's focus in. We can do that later. Let's focus up here. Okay, negative x plus x. We'll cancel out. Our next one, 2y plus y, is going to be 3y. Z plus negative 2z is going to be negative z. And 2 plus 5 is 7. So there's our one equation with 2 variables. Now the other equation, our x is 2. So we have to multiply our 1x by 2 to get them to be the same. And we're not just going to multiply the x. We actually have to multiply the entire equation by 2. So we distribute the 2. 2 times x is 2x. 2 times y is plus 2y. 2 times negative z is negative 4z. And 5 times 2 is 10. And again, we're going to eliminate x. So we have 2x and 2x. If we added them, like we did the other one, 2x plus 2x would be 4x, not 0. 2x minus 2x, 2 minus 2 is indeed 0. So here we have to subtract. Also, when the signs are the same, we subtract. Our next one, 3y minus 2y, is going to be 1y. Just y. Negative z minus negative 4z. Our negative and negative make a plus. So negative z plus 4z is plus 3z. 9 minus 10 is negative 1. Now at this point here, we need to determine if we're going to eliminate y or z next. Doesn't matter which. I'll pick y. So to do that, I'm going to have to multiply this equation here by 3, because we need the y's to be the same, because we're really asking what times y would give me 3y. Well, that is 3. So 3 times our y would be 3y, just like we wanted. 3 times 3z would be plus 9z. And our negative 1 times 3 is negative 3. 3y plus 9z is equal to negative 3. Now, since we have 3y, positive 3y, positive 3y, since the signs are the same, we're going to subtract. 3y minus 3y is 0. Negative z minus 9z would be negative 10z. And lastly, 7 minus negative 3, the negative negative make a plus, giving us 10. Since we now have one equation with one variable, we would divide both sides by negative 10, telling us z is negative 1. Now at this point here, we just need to solve back through. So the one we could pick is y plus 3z, so that'd be 3 times negative 1 is equal to negative 1. 3 times negative 1 would be negative 3. Add 3 to both sides, telling us y is equal to 2. And last but not least, we need to pick one of the original equations. Borrow that. So x plus y minus 2z equals 5. I just picked the top one. Doesn't matter which one we pick, because all 3 will give us the same result. So now we just need to simplify. We have x plus 2, or negative 2 times negative 1 would be plus 2, is equal to 5. Our 2 plus 2 is 4. At this point here, we would subtract 4 from both sides, telling us x is 1. So our final solution would be 1, 2, negative 1. Questions on this here? You feel good about these so far? Okay. All right. We ready for the lesson today? All right, continues to do that, but it does. Adding and subtracting matrices. To add or subtract 2 matrices with the same dimensions, add or subtract their corresponding element. The only way we can add or subtract 2 matrices is if the dimensions are the same. They have to be the exact same. And then we add or subtract the corresponding elements. Now, you don't have to write this down, but if we look at this here, so the first one, adding. A is in the top left. E is in the top left. So we're going to do A plus E. B is in the top right. F is in the top right. So we do B plus F. C is in the bottom left. G is in the bottom left. So C plus G would be our solution. We add the corresponding elements together. Subtraction is almost the same thing, but instead of adding, we are subtracting. Okay? The sum or difference of 2 matrices with different dimensions is undefined. If the dimensions are not the same, we cannot add or subtract. It's just undefined. So we can have the definition. Let's actually look at an example, because I think it's easier to understand an example of us actually doing it than trying to fully decipher what the definition or the theorem just states. So if we look at this here, our first matrix is a what? A 2 by 2. We have 2 rows and 2 columns. Our second one is a 2 by 2. It has 2 rows and 2 columns. Since the dimensions for both of them are the same, we can add them together. So we add the corresponding elements. 2 is in the top left. 1 is in the top left. So we're going to be doing 2 plus 1. Negative 1 is in the top right. 2 is in the top right. So we'll have negative 1 plus 2. 3 is in the bottom left. 4 is in the bottom left. So we'll do 3 plus 4. 0 is in the bottom right. Negative 2 is in the bottom right. So we'll do 0 plus negative 2. So the corresponding elements here are being added together. So where they line up, where they match up, we'll add together because they're corresponding elements. Questions on how we did this here? 2 plus 1. 3. Negative 1 plus 2. 1. 3 plus 4. 0 plus negative 2. That's it. Yes. I mean, that's really it. I mean, is it necessary that we have to do this step? Well, no. But if it helps you see what's going together, it's easier to do. Yeah, 2 plus 1, negative 1 plus 2, 3 plus 4, 0 plus negative 2. So this next one, we have a 3 by 2, and we have a 3 by 2, yes? So we're going to subtract, and we can subtract the corresponding elements. So the first one we'll have is 2 minus negative 1. Then we can say 5 minus 7. Then we'd have negative 2 minus negative 5. The next one we have is negative 3 minus 2. Then we can say 4 is 8 minus 6. 2 minus negative 1. Well, the negative and negative make a plus, so it is 3. 5 minus 7 is negative 2. Negative 2 minus negative 5. The negative make a plus, so we have negative 2 plus 5, which is 3. Negative 3 minus 2 is negative 5. 4 minus 8 would be negative 4, and 8 minus 6 is 2. That's it. When we add or subtract, the dimensions have to be the same, and the dimensions of our final answer will be the same as the other two. Yes.
You are?
Mm-hmm.
I don't know which.
Yes.
Off the next one.
Mm-hmm.
There's a 3 by, a 2 by 3 and a 2 by 2. I'm going to try to, how would you do that?
So, all right, guys, let's look at this one here. It is. So, yes, this one here is not possible. It's undefined. Because
So if it's like that,
our first one's a 2 by 3, yes? 2 rows, 3 columns. The second one is a 2 by 2. Are the dimensions the same? No. So it's undefined. And here's why. So let's act like we're trying to add these. because it'd be negative 8 plus 6. Then we'd have 1 plus negative 1. And then we'd have 3 plus nothing. There's nothing there. Well, maybe we could add a 0. But if I add a 0, the dimensions is not a 2 by 2. It's now a 2 by, it's not the same matrix. We changed it. So this here is undefined. We can't add or subtract two matrices that have different dimensions. Almost. This is our addition subtraction, yeah. Scalar multiple. Not with multiplication or addition subtraction. Questions on this so far? All right. So we feel good with addition subtraction, yes? All right. Now the calculator can do matrices, yes? So the next one we have, what I can do is go second matrix, over to edit. And the first matrix that we have for this is a 2 by 2. Negative 1, 7, 5, 3. So, this, so we see this one here? Yeah, so A, so the problem number. So we have this. I've typed the first matrix in for this problem, yes? We can go second, quit. Second matrix. Over to edit. But this time I'm going to go down to matrix B because we have two different matrices we're wanting to add together. So I can hit enter. And it's also a 2 by 2. 6, 4. So I can quit. Okay? So we feel good with being able to put them in. Yes? Okay, I'm going to recall matrix A. So second matrix A plus second matrix B. Because that's what we're doing. The one we put in A is being added to B. 5, 3, negative 3, 5. Calculator will do it. But especially with the addition subtraction, well, we can do negative 1 plus 6 is 5. 7 plus negative 4 is 3. 5 plus negative 8, 5 minus 8 is negative 3, and 3 plus 2 is, with addition subtraction, especially these here, we could do it by hand as fast, if not a little bit faster than we could type the thing in. So sometimes it's easier just to work it out. Like the next one here, 2 minus negative 3. Because our negative would make a plus. So 2 plus 3 is 5. 5 minus 0. That's it. Are you ready for the next one? Because the first one's a what? A 2 by 1. So this first one is considered a column matrix because it has exactly one column. The next ones are called a row matrix because it has one row. Up and down are our columns, left and right are our rows. So it's a column and a row matrix. But since the dimensions are not the same, this is undefined. I can't add or subtract them, but if we did multiplication, we won't do that yet. We will do that at a later time. These can multiply. Do we need to see another example of addition or subtraction? It's 2, 4, negative 4, 10. Yep. So the first one, so dimensions is rows by columns. So 2 by 1. Here we have 1 by 2. They have to be the exact same. So 2 by 1. So for these to add, dimensions of the second one have to be a 2 by 1. So if the dimensions of them don't look the exact same, it doesn't work.
So if
Yeah. Yeah. So the rows and columns, the dimensions have to be the exact same. So a 2 by 1 can be added with a 2 by 1. Yep. So if they're not the exact same, it's not possible. Undefined. All right, guys, we ready for the next piece? Scalar multiplication. All we're going to do is take a scalar, a number, and multiply the matrix by it. And we take whatever that scalar is and multiply it by every element in the matrix. Yep. So this first one here, we have this matrix.
Put 2 times 3, 2 times negative 2.
Yes.
2 times 1 and 2 times 5.
So when we scale something, we're making it bigger or smaller. It's our vertical stretch shrink kind of. So we're scaling this by 2. So every number in this matrix is going to be scaled by a factor of 2. So we're going to have 2 times 3. 2 times 1. 2. Yes. Yes. 2 times 3 is 6. 2 times 1 is 2. 2 times 2 is 4. 2 times 2. 2 times negative 2 is negative 4. 2 times 5 is 10. 2 times 0 is 0.
This is a lot easier than 1 by 5, 1 by 4. Yeah, 1 by 5, 4 was 1 by 5 has a lot of steps and can't get easy.
But also 1 6 does 1 5. Because we saw how to solve them at the end. So we good with this one here? We ready for the next one? Because yes. So I think we feel good with scalars, yes? Okay. We're going to combine what we did with addition, subtraction, and scalars. So whenever we do this, the first thing we'll do is do the multiplication of the scalar. So we'll distribute the negative 3 through. So negative 3 times 5 would indeed be negative 15. Now we'll negative 3 times 0, negative 3 times negative 2, and negative 3 times 4. 0, 6. Now I will say, yeah, that's not supposed to be there.
This matrix doesn't have a scalar, so there's nothing to multiply.
Yes. Yeah. Because we can multiply it by 1, but 1 times negative 1 would be negative 1. 1 times 7 is 7. 1 times 3, 1 times 2, it's not going to change anything. Then we can just add these together. Negative 15 plus negative 1. 0 plus 7. 6 plus 3. Negative 12 plus 2. And our negative 15 plus negative 1 is negative 16. 0 plus 7 is 7. 6 plus 3 is, and negative 12 plus 2 -10. Now, when we start getting multiple scalars and this kind of put together, then the calculator gets to be a little bit quicker. Because we can do this in the calculator. So, if I pull the graphing calculator up, first thing I need to do is put in matrix A, which is a 2 by 2, 5, 0, -2, 4. Then I go to matrix B, 2 by 2, -1, 7. Ah, thank you. It was a -4. It was negative. So it does the same thing, and we can just type it in as we see it.
So that'd be
As,
yeah.
I'm just making something up. Yeah, because the scalar is just a number. We're scaling it by. Now, so guys, one thing we can't do is we can't divide matrices by anything. So instead of dividing, we multiply by a fractional number. So instead of dividing it by 2, we multiply it by 1/2. Because there is no matrice division. We have to do the reciprocal of multiplication. Questions on this here? Do we need to see another example of any of this? Okay. You have the rest of the time to work on the assignment. 4 through 8. You're just adding and subtracting those there. 7 and 8. Describe and correct the error. So there are 2 parts of that. We've had a few of these so far. There is an error in something that they did. If you're having trouble seeing the error, so the problem for number 7, 1, 2 plus 7, 8, go on and add them and see what you get and then compare it to what they got. Yep. So.
Yeah, they literally just.
So.
Is 4 through 8 also on?
No, just 4 through 8. Yes.
So it would be 9, 11, 13, 15,
17, 19, 21. Yes.
Okay.
Yeah.
So I'm slowly going through and getting
Mm-hmm.
So this is 1.
Yeah.
Yes.
16 is
Okay. Just bring them to me when you get them. Here, I don't need that. Yeah.
So I don't do 11?
Yeah. So Traven, as you were saying, so for half of 7 there, is they put it together. They didn't actually add. Something of that context describes the error. Then you just need to put what the answer should be, is all it's looking for. Now, it doesn't have to be exact wording, or as long as you convey that you understand what they did wrong, I will take it. 17, 19, 21, if you notice, if you're looking there, A, B, C, all that is A is defined by that matrix there, B is there. So if you want to use the calculator for that, just match it up. Put A in A, B in B, C in for C, and just type it as you see it. If you do have questions, please let me know.